This is SEEK Bytes, the software engineering podcast by Seek.com. Join our experts as they share their thoughts and tips on mastering the craft of code. From career advice to technical deep dives, SEEK Bytes is a podcast for software engineers by software engineers.
Hey, welcome to the SEEK Bytes podcast. This is Seamus. I'm here with Nik Skoufis, Reyna Tan, and our special guest to talk to you about GraphQL today, Mark Cheesman.
Hello, everyone.
Did I say that right?
You certainly did.
All right, good.
Or Hombre de Queso, if you want to go by my other identity.
Your GitHub handle?
Ooh.
That's the one.
Ooh, the alter ego.
That's right.
Nice. So today we were just going to be talking a little bit about GraphQL, I suppose, talking a little bit about some of the experiences that we've all had in the journey of migrating a lot of our systems to use GraphQL over the last half a decade. I think when I first joined the company, we just started the journey into GraphQL. So it's probably been about 5 years, I think, right?
Seek's gone pretty heavy on GraphQL, right?
Yeah.
I haven't been here quite 5 years, but
Right.
looking around at the landscape, it seems like candidate, hirer, indirect, everyone's got a GraphQL service.
Yep.
Maybe some more.
Yeah, I mean, there is aspects of it in our interview process. That's how much it's ingrained into the way that we build services at Seek.
Mm-hmm.
I guess I realize maybe there's probably people who aren't fully aware of what GraphQL is. Who feels like they're in a good position to explain what GraphQL exactly is and why we're using it as well?
Putting people on the spot now.
Yeah. Well, I mean, at heart, it's really a query language and a definition of how you populate the data on the query. So I guess you could imagine parallels to it, for example, might be the SQL query language. It's a language that defines how you query and get data out of a relational database. GraphQL is essentially a query language, a definition of a language, and a high-level implementation mechanism that essentially involves traversing a graph, like turning the query into a graph and then traversing it and populating the data in it. And that's essentially what it is.
Yeah, that's. I like that answer. I probably would have had a much more caveman. It's an API that sits between your API and your UI.
That's a very highbrow answer, Mark.
Yeah,
it's
I like it.
Conceptual, but in a good way.
I think, one thing that you brought up there that's maybe something we've struggled with communicating a bit is that people do think of GraphQL as an API. And there's this, I suppose, blurry line that the GraphQL service is sitting behind a REST API, but for anyone who's done the different layers of REST services, I mean, essentially it's not actually a REST service. It's just a massive pipe that you open and shove data through, and there's not really anything REST-like. And I suppose a parallel I use sometimes is that there's no reason that the GraphQL service should be an HTTP-based service. Nothing stops you, for example, putting it behind something where you dump queries into a queuing system and, like SQS, and something pulls the query out and executes it on the graph and then dumps the result somewhere else. And this is probably a distinction we've had to sort of tease out over time, because people have a naturally sort of blurry sense of, are the headers part of the query? And it's probably one of the biggest issues we've had to deal with, because obviously technically nothing stops you just using whatever is on an HTTP request.
Yeah, that's interesting. Does GraphQL support different transports? Can you do it over gRPC or something like that?
You can pretty much do it over anything you
Right.
want. I guess the GraphQL as such is just a definition of a query language, and then there are implementations of it. Right. Probably the Apollo one is one of the more popular ones, and essentially that is really I suppose, something just for building a GraphQL server, but you probably shouldn't think of that as it building an HTTP server. You build a GraphQL server and then wrap that up in something like an HTTP server.
Right. An HTTP interface with
that's
HTTP
right,
semantics that then get translated to.
Yeah, so if you're, using Express or whatever's your, preferred HTTP server, really it's just the mechanism for transporting the query, and you could be theoretically using anything at all that is capable. I guess you could, if you didn't mind it being lossy, use UDP or anything you like. You might not be your best choice, but you can, anything that can transfer data backwards and forwards.
Nice. So I guess being that you're the guest today, Mark, what can you talk a little bit about the process of moving to GraphQL?
Although you might know more about it than I do, because I've only been on the team for a couple of years, but I believe before my time, about 5 years ago, some people put in a GraphQL service in the candidate system, which is probably what people would think of as behind the SEEK.com website. Mm-hmm. And people started using it, and I think by the time I joined, they eventually had to make a team to look after the GraphQL service, which originally I believe it was a bit of a free for all for a couple of years.
The shared domain, right? Everybody was sort of contributing, which has its pros and cons.
Yeah.
Lots of things can get done quickly, but
so is that there was one GraphQL endpoint that everything when we say shared, what do we mean by shared?
The whole the whole repo, the whole Hira GraphQL API everyone was admins of it. Everybody could contribute to it. There was no proper custodianship.
Right. Okay.
Yeah. So it's it became a very multi-opinionated space.
Yeah.
Which is, I think that's what you're talking about, right? We started to have that moderator team to take care of that and make sure things stayed consistent.
Yeah, so I think that was probably the experience at SEEK, was that it's not so much an issue that lots of teams are putting their stuff through GraphQL, it's just that everyone's doing it in their own way. And so there needs to be a bit more order on that. And I guess the other aspect that was probably not being attended to is that the GraphQL service as such is a service that someone has to look after, and everything from trivial things like who's going to do all of the package updates and things like that don't get looked after unless there's someone motivated or you end up actually having a team behind it. So those things, and then there's a whole lot of other features you can build that are maybe not specific to any particular team putting their data through the graph, and those are the things that the team started to pick up. And I've been on that team for a couple of years now.
And I'm possibly in this podcast going to be a little bit of the maybe asking some of the potentially very simple questions, because I've never run a GraphQL service in production. I've consumed. I may use a GitHub GraphQL endpoint sometimes, but how intermingled is kind of the HTTP semantics in GraphQL in terms of the implementations that we use? We use Apollo, right, which is a TypeScript library. Are they? Can you very clearly see the seam between the HTTP server part of that and the GraphQL bit, or are they a little bit more commingled?
It probably depends on how you build it. Okay. I would say our implementation of it, so when you execute a query on the GraphQL server, it has a thing called the context, and the context could be nothing, but it could be all sorts of other things. So probably the most common thing that you might find on the context, for example, might be an auth token or some mechanism that you're doing the auth through. Now that, of course, if your GraphQL server is sitting behind an HTTP server, is going to come off the auth header.
Right.
And that's where I guess it starts to get blurry. Like if you say, well, is that the auth header? Technically the answer is no, because it's just whatever's the auth that you've put on the context.
Yes.
Did it come from the auth header? Well, undoubtedly that is how it got there.
Right.
And so we actually, on our context, for historical reasons, there is actually an object that is headers, which is literally just a raw dump of all of the headers. I probably, if I was building a GraphQL server from scratch, wouldn't put that on there.
Right.
It's just that, and we're trying to tease people off it over time. What we've replaced it with is the I suppose rather than just dumping headers, you put specific values in the context, because then, and they might be populated from headers, but what that then says is that once you're within execution of the graph, you shouldn't really be thinking of those things as headers. You just think them as before the query got executed, the system set itself up to operate in a context, and the execution of the query occurs within that context.
Yep.
But in theory, you could put it behind an SQS queue and use headers off an SQS message to populate the context.
Yeah, that makes sense.
Yeah, it's really interesting. Having only worked with, this is the only GraphQL service that I've ever worked with in a production environment. I hadn't thought about that either, and I think it's changed the way that I'm thinking about Graph as we speak, because I've always just seen it as an API that sits between those two layers. But you're right, like any of these things that we build, do they have to be Lambdas? Do they have to be APIs? I like that. That's an interesting perspective. So I guess makes me think how much time some of us have spent with GraphQL. I imagine being a newer technology, and most of us having been, I know that I've been at SEEK for 5 years. And Reyna, how long have you been at SEEK?
Not 3.
3? Yeah.
3 as well.
3?
4.
4? Yeah. So for all of us, I'm imagining this is probably the only production Graph environment we've worked with, unless we've got some side hustles or something that's using Graph, which would be a pretty impressive side hustle if you've reached that level of scale demand, right? Yeah, no, I like that. That's interesting. Makes me wonder what some of the other challenges are that we've faced while building this shared GraphQL layer. It's obviously, if people have an understanding of what that layer looks like and they're perceiving it as an API, that might drive the way that they think about consuming it. I know one thing that I've seen, I think probably one of the more common things, is people just plumbing through the exact same values that came from their API.
Yep.
Yeah. So I mean, there are different models, I suppose, for how you might build your graph. There is, I mean, at heart, you have to end up with a schema definition at the top that says this is the data that's coming through and that someone can access. One way to do that is to largely surface the underlying API's data almost one for one through the graph. And I guess if that model suited what you wanted to do, there's theoretically nothing wrong with that. If the graph will still achieve one of its primary goals, which is that the UI client does one request through to a server, and the server does whatever it has to do to collect all of the data and hopefully does it as efficiently as possible. And some GraphQL servers do, if you look at their contracts, do look a lot like that's what's happening, and they work perfectly fine. I think the way we went it with the candidate graph was rather than focusing on the underlying data sources, are trying more to think about the schema, which is the definition of the data that you can get from the graph. We think of that as essentially being the UI's the UI client's domain. So we start from thinking, well, if there's UI clients up there, what sort of conceptual domain would they want to see? And examples of that, for example, might be that simple things like if you've got a date time, Do you just pass it through as a UTC date time? Well, in the UI domain, it's pretty rare you're going to actually just display a UTC date time to a user. So as with a lot of companies, SEEK have definitions of specs of here's how we want dates to be displayed. This is the short version, the long version, the super long version, the whatever versions you want. Those are all constructed within the graph, and then that means that the data coming out of the graph is closer to being, I suppose, what someone building a UI would think of as this is just exactly what I need to display, and I don't need to go and read the SEEK standard spec and then fuddle around trying to implement it because it's already been done.
It's interesting.
And that's offered a lot of benefits. So because you build it once, it's in the graph, every single API passing data up through the graph essentially surfaces their date times in with a type that has all of the different ways you might want to display it available. And it's built once. Mobile, iOS, Android, web, they all use the exact same thing.
Nice.
So that offers a lot of advantages we've found.
And if I can ask what I suspect is a very difficult question, which is how does that play with localization and translation and different locales?
It's a good question. And the answer really is just exactly what you would think of if you've got a function and you want to get the date time string formatted, you have to tell it exactly what you want. So we have a date time type that has the different formats, and you ask explicitly for the long or the short version of it, and at the same time you can also specify a time zone and you can specify the locale. The way we've built it is we use things like the locale probably more as a suggestion. So we're trying to obviously make sure that we can always display something. We don't want to return nothing. So you might ask for your date time, the short form of the date time in, say, the Perth time zone, and you want to see it in, I don't know, French. Probably won't be able to do that for you. The Perth bit's okay, but could display it, because there is no definition of how to do it in French for the SEEK website, but it would fall back to English. But if you specified any of the languages we do support or the locales we do support, you would get it back in that format.
Mm-hmm. And so are those parameters directly in the graph query, or are they?
Yeah.
Okay, gotcha.
So it looks a lot like a standard function that you ask for a property or a value, say short, date, time, and then there's some arguments to it, and you specify the arguments. If you don't, it usually sensibly defaults. For historic reasons, it will usually default to English in the Sydney-Melbourne time zone, because that's sort of how the system grew up over the years.
Sure.
But we do prefer people to explicitly specify, because it just makes it easier to understand what's happening when people go fishing to find out what's happening.
Yep.
Yeah, I think that's one of the big advantages that I see with Graph is doing that like obfuscation stuff when you've got some values that might be, really kind of important for your business, and you do want your API to return those values for some scenarios, but for your UI consumers, you want to make sure that you're obfuscating that stuff and hiding that protected business behavior. I think GraphQL is pretty much like the only thing that I'm aware of where we can do that, other than just, I guess, proxying behind other things. But that's, at the end of the day, that's kind of what Graph is, right? It's a proxy between the two layers. So, Reyna, have you had any particularly, interesting or unenjoyable, both ends of the spectrum, experiences with Graph?
Unenjoyable. I think I would go into the interesting bit. Oh, actually, you could say at times it was unenjoyable because my brain was about to explode. But learning how the GraphQL engine actually executes, learning about that. How to write your resolvers in a way that ensures that your GraphQL is executed in the most optimized manner. And because it kind of actually goes back to all that graph theory that you would learn in university. My brain was like,
does it
how
really?
do I traverse this thing?
That's exciting. Maybe I should get more interested in graphs.
It's
Studied
really
a little bit of
interesting.
mathematics back in university and a little bit of graph theory.
Yeah, and going back to like how the graph executes in a depth first. Oh no, giving myself away. There's quite interesting things like the GraphQL JavaScript package provides you with some traversal functions that you could use to do interesting things like collect metrics for how your graph is being used, figure out which parts are most used, and I guess optimizing that. So that was really challenging. Mark was there. I had to knock my head on the wall a few times to know what is going on. Yeah, that was good though.
Nice. You've reminded me about the depth first search behavior and the actual mathematical graph behaviors that the graph is built around. It's funny, like Mark was saying before about most people are just looking at it like an API. I'm definitely in that bucket of people that have just been thinking about it like an API. I mean, I know these things. I know that it's a query language and not an API. I know that it has these graph behaviors, which is why it's modeled like a graph. But once you've just been consuming it for a couple of years, you just fall into the rhythm of I've got to make a query, schema, mutation, XYZ, put the pieces together, and then you've got your pipe.
And that's completely fair enough. I don't think like if I wasn't on this team that is like looking after or like are custodians of the candidate graph, I wouldn't have thought about how do we observe the performance of the graph or how it's being used. What can we do to make it better? Those things probably falls into the hands of the graph custodians.
It's probably one of the reasons why we need custodians of the graph, right? Otherwise, people are just consumers. Even if they are contributors, they're just consumers before contributors. You know what I'm saying. Yeah.
And so you touched on an interesting point there, Reyna. I think a bit of the architecture of the graph. Do you want to talk a little bit more about how GraphQL APIs are kind of architected on the sort of the upstream side? Is that what we call it? What's the terminology here of the bit that goes out to the other APIs that the GraphQL API sits in front of?
Yeah. So the architecture of that. What do you mean by that?
Oh, just like let's say I'm coming along and I want to integrate a new API behind the graph. What do I need to build? What kind of components exist that are sort of reusable and are going to look like the other ones? How do we get that whole mess to work, for lack of a better way of saying it?
So in the Canada Graph, we're using the Apollo GraphQL server, and Apollo has inbuilt packages or classes that you can use to set up your data sources depending on what your data source is. It could be a REST API, typically. It could be an S3 bucket. It could be other things. I can't think of anything else.
Sure.
In-memory file. And, well, the Apollo's REST data source kind of comes with several features that you can use to optimize, whether or not you need to make this call again, because the graph, your query might hit the same API multiple times. And we try to make sure that we only hit it once with the information and not with the same information. So if you had a REST API and wanted to hook it up to the graph, you would, create a class inside the graph and basically add it into, that context object that Mark was talking about, creating so that the resolvers was, I feel like I'm tossing up technical terms.
No, that's okay. It's a good opportunity to talk about a resolver.
When the graph is executing your query, it knows, I've got all these available data sources. The functions that are trying to resolve that query, they'll go off and grab those data sources and make a request there. Yeah.
Okay, so let me ask a follow-up question there. So, okay, I've got a GraphQL executor. Is that the right terminology. I'm looking at Mark. I'm looking at it right now. I've got a GraphQL executor, and it's executing my query.
Yeah.
And it is calling a resolver. Is that the right? It's calling a resolver. And is there a one-to-one mapping between a resolver and a data source? So do I call this one resolver and then it goes to the data? No. Okay. So fill in the gaps for me there.
Okay. Looking about.
Mark or some specific people.
Yeah. So I think it would be, you could start by imagining that maybe there could be a one-to-one correspondence. So your query says, get me the job data. Yep. So there'll be a in the schema a type called job, and you say I want job 1, 2, 3, and you could imagine that has a whole lot of fields on it that you're interested in. Mm-hmm. And in the most simplistic situation, it might be that the resolver, as the graph sort of says, the root is a query and the query has a job on it, and it hits the job resolver.
Yep.
In the most simple case, the job resolver would potentially just hit a REST API and say, get the job data for job 1, 2, 3, and then it'll simplistically just copy the properties across.
Gotcha.
Then you could kind of imagine that a layer of complexity over that is that maybe the job API just returns you a UTC date time, but you want to return a string version of it that is in a time zone and in a language that is displayable on a UI client. So you might add another property on there. Mm-hmm. So I suppose what that introduces now is this idea that you have a type job that has a property on there that didn't actually come from a REST API. Okay. It was populated based on values it got from that API, mm-hmm. but you're actually doing some processing to provide what that field will be.
Right, and so then is the terminology there that there's a sort of job resolver that will call this job's data source?
Yes.
And does it call another resolver to do that date-time conversion to the correct format, or is that?
Yeah, so you could. So the way we've done it is that in this case, for example, the job type, which is the schema definition of what you can get from the graph, yep. in turn might have a date created. And instead of that being just a UTC date time, that itself is a type that has various ways that you might be able to get the date time for display purposes. So now you can imagine that your query comes in, goes to the root node, which is the query. From there it traverses down and says, oh, I've got a job. The job causes it to hit the job API and get the data it needs, and maybe most of the properties just, magically line up. Yep. But then it discovers, I've got this other type on there that is the date time, and so then there will be a date time, or we call it the SEEK date time type to make clear its definition of how we want the date times displayed. And so then it will traverse down to that node, or the resolver for that node in the graph, and then get the data that it'll already have the UTC date time, and it will do whatever it has to do to fill in the fields that you've got there.
Right. So, okay, it sounds like it's not a resolver per kind of type; it's a resolver per node in the graph. Is that
so? What would be true to say is if you have a type definition, you could have a resolver for that specific type. That's one way to do it. Okay. But you could also write a resolver for every single one of the properties on that type. So you've got a few different ways you can do it. Right. Or you can be lazy and just write a resolver one and just grab the data from the API and hope to goodness that everything's there.
Gotcha. Okay.
But yeah, essentially technically in the definition of GraphQL, there is no such thing as a data source.
Okay.
That's an implementation detail for how to get the data. So, and this is, I guess, another one of the distinctions that I found when I was learning GraphQL, the best thing to do was actually, build my own little toy server, and not actually have any REST API data sources. I would have in-memory data, and I sat there for hours just trying combinations of things and having it, console log execution plans and things like that till I understood, actually that's what GraphQL actually is. And then afterwards brought in the idea, sometimes I actually have to hit a REST API, so how would I manage that? But to understand that is an internal implementation detail and not actually GraphQL as such.
Yeah, that makes a lot of sense. Yeah, interesting.
Yeah, like that's what our Apollo client is taking care of for us, right? It's taking care of the bits that we think about in layman's terms as being GraphQL, but in reality, like you said, it doesn't need to be APIs, doesn't even need to be HTTP, right? It can be some entirely other network layer.
Yeah, and we have a number of data sources, different types of data sources. I think Reyna mentioned a few of them. REST APIs are by far the dominant ones, but we have S3 buckets. We have things that we just hold in memory. We have a Redis cache that we use for certain public data. That's obviously being initially populated on first hit of other data. But nothing stops us using that for any other sort of data we want. So it can be anything that can provide you with data.
Nice.
Fast. That's fast. Has to be fast.
Has to be fast.
It's not fast. We will punish you. Somehow.
Yeah, and maybe that's a good point to talk about. Something I'm curious about is some of the performance constraints and performance considerations when you're operating a GraphQL server at scale.
It's interesting. You were just starting to touch on some of these things. So you were talking about resolvers, right? And you can just have like a high-level resolver and just blindly go, give me the universe, show me what you've got. But we tend to push people towards field-level resolvers. The idea that if every field has its own resolver, then you are only executing as much of the query that you need to. So from a performance perspective, only ask for what you need. Don't just get a giant blob and then grab what you need later.
So that was going to be my other question is Reyna mentioned that the data source, and this is the question here, is it the data source that's set up to say, I already have this data, I'm not going to refetch that from the API, or is it the resolver? And so kind of playing into Seamus's point that, okay, if you have a resolver per field, the resolvers must have some shared state where they know that they fetched this data from the same data source recently, for some definition of recently. Is that a rough approximation of how it works?
No, it's actually the...
That's good, I'm learning things.
It's the data source that has that state.
Okay.
So the data source has its own internal cache. It's called like memoization, that you can it's an implementation detail. You can decide how you want to identify what object you've already fetched.
Yep.
Typically it's based on the URL. And so when the field resolver calls the data source to say, hey, hit this URL, get me this data, it will first check its internal cache. Do I have it? And if I do, return it. If I don't, I'm going to get it. Yeah.
Okay. It makes a lot more sense than what I suggested, I think.
You have state when you cache data, and if you're doing something in GraphQL, you almost certainly will be having to manage state. You have to manage state on REST API calls just simply because of the way the graph executes, and you need to be, as with any state, very, very aware of things like the life cycle of the state. Are you holding state that's related to a particular person's data? Because sometimes you do have to do that. And those are infrastructure related things about how the graph executes. And it's reasonably easy to make mistakes on those things if you're not really clear. And as I said, if you're using dynamic frameworks that happily accept functions or objects, and it's easy to flip between the two, you can end up with dramatically different behaviour on your graph where the dramatically different behaviour is not one that you want to see. But understanding that, of course, means that in turn you can also, when you understand those things, optimise your graph's execution for certain things, because maybe there are things that it's okay to have state crossover between requests, and we manage that. I think that's probably something people need to think about if they're building a graph. Is if you just do a free for all, you're going to have mistakes happen, and we have very clear, I was going to say guidelines, I'm going to say laws, for which you will be punished by your PR not being accepted. But things like we have a Redis cache. The Redis cache data obviously is accessible across different requests. So you are only allowed to put public data in the Redis cache. And this can be a problem because we've had cases where people had things that ran inefficiently, and it's like, can we use the Redis cache? And it's like, no, you can't. And like, why not? It's like, because, and you have to explain it, but, there are ways to fuddle it, but of course once you start fuddling it, then you're introducing the probability of an error. I think setting those guidelines up so that people understand, yes, I can access anything in the Redis cache and I'm not going to accidentally forwards one person's data onto another person.
These are all implementation concerns, right? Like this is just dependent on the technologies that you're using and the way that you've set up your GraphQL implementation. GraphQL itself doesn't have state stuff, does it?
GraphQL is just a definition of a query language and a way to execute it.
Mark, we might need a plaque for you that has that on it. And you can just kind of, don't make me point at
it's just a language. It's just a query
language. It's a very good point.
Well, what state do you want it to have? It can have any state you want it to have, however you implement it. But I think if you pick up any of the standard frameworks, they obviously help you to at least, if they're any good, if you like, fall into the pit of success when you get started on these things. But it's probably something people need to be aware of, is that if you're putting a graph into your system, you're probably not doing it because you've got one or two APIs. You're probably doing it because your system's approaching a level of scale where this is going to provide benefit for the scale. And the default pit of success is the default pit of success that any system has, which is just a helpful place to start that most likely will work for a lot of people. But you really do need to look at the specifics of your system and understand what the default thing is doing, because it may well be perfectly fine. And for a lot of our stuff, it is perfectly fine. But if you don't understand why it's doing what it's doing, when you do have performance problems or when you do have things that you want to achieve that don't seem immediately apparent, if you don't understand how it works, you're liable to do something that could cause other side effects.
Yeah, you sort of touched there a little bit on something we haven't covered yet, I think, is like, why did SEEK move in the direction of exposing all of our APIs via these GraphQL endpoints, as opposed to what presumably, again, I've only been SEEK 3 years, but presumably what we had before, which was just, if you needed, correct me if I'm wrong here, if you needed job data, you hit the job API, and if you needed, what's another example? If you needed location data, you hit the location API, and now it's all kind of wrapped up in a nice GraphQL interface. Do you want to expand on why we did that a little bit?
Yeah, I mean, it happened, I guess, before my time,
Sure.
But so I can't speak to exactly the motivation. Maybe the original people read a
general
blog post and it
motivation
sounded like a good idea for all I know.
I do have some insight on this, actually, because the first team that I joined at SEEK was the mobile team. So I was working in iOS, and at the time we had a lot of experience APIs to try and, make it more consistent across the different experiences. And so Graph was the natural evolution of, it seemed like the most obvious answer to solving the problem of bringing together the mobile and web experiences to make it more consistent in the way that you access them.
And I think, and that's probably where, I mean, I joined the team at a point where I think roughly just under 20% of requests from UI clients were hitting the graph. So some progress had been made in that direction, but a couple of years ago we still had all of the mobile experience APIs. There were also web experience APIs, so it was even more messy than what you were saying. Like, you could imagine if there were no experience APIs, everyone would be building their code to hit the underlying resource APIs. But it had already progressed in the direction of let's put in a layer of experience APIs. And at that point, there was just a lot of combinations of things. So sometimes UI clients would be hitting resource APIs. Sometimes they'd be hitting experience APIs. There were different experience APIs depending on which teams were involved. So, you're getting right into the Conway's law issues. If you make two teams, you're probably going to end up with two systems there.
Gotcha.
And so, essentially the graph, was intended to solve that problem amongst others. And I think now we're pretty close to getting rid of all of the experience APIs. I think we're probably well up over, we'd be getting over 95% of the traffic by now.
Right, okay. And so effectively we're saying that the reason we went down this path was we wanted that experience API. I'm right in saying it's kind of that back end for front end type concept where you're taking some APIs, aggregating them, and then providing data in kind of a pattern that matches what the front end needs to display a bit more closely. And then GraphQL is the evolution of that, where we're not going to have these tailored experience APIs. We're going to give you effectively a query language to to build your own experience API in some sense on every request, which is pretty useful. Yeah,
and I think that possibly helps people think about what the problem is that's trying to be solved here, is that there's different ways to solve it, and there's nothing wrong with experience APIs. In fact, one of the advantages of REST experience APIs is that you have a very strong amount of control over what happens when they execute, because there are specific things that can happen. And so, if your use case is that you're really just trying to aggregate certain amounts of data in virtually always the same ways, and you want to have a lot of control over it, and maybe you don't want third parties to have to be able to query your API. You don't need that flexibility. Then experience APIs definitely are worth considering, I think, because of the control that you have over it. The disadvantages normally with REST APIs at the experience layer is that to build flexibility into the way REST works, we're all, as people have probably seen cases where as part of your query, your REST query, you can say, these are the fields that I want, and then only those are the ones that you'll get back.
Yep.
That's essentially something that's solved in the graph in a different way by you just saying, the query itself defines as part of your query what you want. And that probably sort of indicates what would happen if you tried to get the flexibility out of a REST experience API. You would probably inadvertently build, if not GraphQL, you would build something of equal power and complexity if you did it correctly. And in a sense, GraphQL is trying to solve that problem. Like, how do we get this flexibility that we want, ability to add on, ability for everyone to then use it. And although we don't have third parties using our API, it's quite a well-known mechanism for providing a very flexible way for queries that you haven't imagined that people might want to exist. That's usually the problem, is that we all think about the use case we know, But what about the ones you don't know? And the ones you don't know, often if you've got a REST experience API, you may well have to then go and do work and build queries that are specific for the ones you didn't think about.
Yes.
If there's no new data specifically involved, you are likely to find more often than not that you can perform a query on the GraphQL using what's already there.
Mm-hmm.
And so that, obviously helps then you don't have to do developer work in order to provide that flexibility.
Yeah.
Of course, there's a trade-off there, which is that, in the worst case, imagine if you had a relational database and you provided an API where anyone can just feed through any query. I personally would definitely try select star from star because why not? That's exactly what we want to do. We want to, see if that's going to cause it to crash or not because it's fun. Now, maybe people aren't. That indicates there's an element of which you can be malicious against the graph. You can create queries that are designed to cause system collapse if you really want to. This is the trade-off. With flexibility, there are performance issues that you need to consider. There's security issues you need to consider. There's a whole lot of things, and that's probably something, if your company wants your website to keep working and you're using GraphQL very early on, if not right from the start, you want to consider those concerns as first-class citizens in what you put in by default. You may not have to invest oodles of time in it, but you should at least become familiar with basic things of not performing queries that are too complex, for example.
Yeah. That was going to be my next question, was really, it feels like you're making a trade-off there between presumably experienced APIs, like you were saying. If you've got a relatively limited number of query patterns and data sources, you've got fairly predictable performance, probably more tightly bounded performance, whereas the GraphQL query could be incredibly efficient and quick if you're only requesting a few fields from one data source, or incredibly expensive and slow. Two questions there. I think you sort of touched on them a little bit, but first one would be, how have you gone about educating people, or how do we educate people about how to write more performant and faster GraphQL queries when there is an option, I guess? And then the second question would be, on the flip side, what safeguards are there to stop, like you said, malicious queries or too long-running queries?
The stopping malicious queries, to start with that one, there's various things that you can put into your graph, most of which are reasonably easily available in the various frameworks. So one that I mentioned before was that you can assess how complicated a query is and say if a query reaches a certain level of complexity, you're just not going to execute it.
Probably comes back to Reyna's point on graph theory back in university. It's some sort of graph theoretic measure of...
That's right, yeah. So you can imagine it, it essentially parses the query into a tree graph structure, and you can calculate from that tree how complicated the query is. So it gets into all that graph theory.
Someone sitting there with big O notation on a whiteboard, just yes.
yes. We have had that in other areas, but that's another story. And then there's obviously, as with any API these days, people just love to get data out of it. People who maybe you don't want to be wasting your company's resources by trying to, suck every job down and all of the details. So apart from, I suppose, simplistic rate limiting based on trying to use IPs or whatever fingerprinting mechanism you might be using to identify who's making the request, one of the benefits GraphQL gives you is that once you have essentially parsed the query, you can then put in certain security measures related to elements of the query. So this is probably if you think about often the top level security levels or the top level systems on your website, it's often things like being able to rate limit by IP and things like that. GraphQL can do those things, assuming you've got an HTTP front end. But then you can also start doing things at the query level and saying, people can't ask for this piece of information or the, instances of this type too often.
Interesting.
So there's a whole lot of things like that. In terms of helping developers write performant queries, often the way the development model works is we often try to, if there's new teams putting their data through the system, we'll work together with them, often pair with them. That's probably our preferred mechanism to help new people get onto the graph, because it helps them move faster if you're pairing with someone, because they don't sort of sit there staring blankly at the screen wondering what's the next thing to do. You can actually guide them through the process. But we've also found that helpful from our team's perspective, because although it theoretically isn't our responsibility as a team to put everyone else's data through the graph, that's up to the teams to do. Our job is to help them succeed in their job, and there's nothing like helping someone to succeed in their job than doing it yourself sometimes. As opposed to, we've all seen that problem, haven't we? That someone goes, I'm going to help you do this, and you go, actually, it's really hard, and they go, oh, no, it isn't. Well, why don't you go and try it? And they just go, and so it sort of stops those problems of people saying, these things don't really work.
Yeah.
We have people from our team regularly helping other people. So, that's probably the main way that we do it. And then, obviously some people have more experience on the graph on various teams, and they just, trundle off and are able to do their thing after that. And then probably one thing we haven't mentioned explicitly, but just observability on the graph becomes a really big issue very quickly. So, because it is this chaotic, theoretically you can almost do anything if the query schema allows you to do it. You need to know what that anything is and who's trying anything. And so there's a lot of metrics coming out of the graph. We keep track of times that nearly everything takes to execute. And if you're the owner of an API that we believe is maybe not pulling its weight as much as maybe it should, you might get it's all about, if someone is in that position, obviously no one does want to be in that position. So it's all about trying to help people get the speed going that they need. But the first step is you've got to know that actually is the problem, and you don't want to be expending effort going, I just saw something over there and I think it's something, so I'll go and, ask that person to speed up their API if actually that isn't really the problem. You want to spend your time on the things that are genuinely the issues. How
good is the support in the sort of observability tools that we use for GraphQL? Because I'd imagine, maybe naively, there'd be some interesting visualizations of if you can form an execution tree for a query, you can probably also break down the execution time and map that back to kind of that tree. And is that stuff that's supported by Datadog, or is it something that you have to run some custom tool that Apollo sort of gives you to take a bunch of kind of traces of this execution and see where the hotspots are?
So, most of the stuff there is tooling. I mean, we're using Apollo stuff. We're using the open source Apollo stuff. So, we're not paying any money to Apollo.
Sure.
Sorry, Apollo. You can pay for certain products. I mean, Apollo has a very comprehensive suite of products, I believe. I've never used them, but there's stuff there that you can use. Before my time on the team, it was decided to, for the most part, produce our own custom metrics, which we feed into Datadog. So we have a bit of a mishmash at the moment that is a sort of a consequence of the way the platform around us has evolved with our own things that we've added in, probably the if we sort of had our wish right now, and we've got most of these things, but they're just spread all over the place. But you can pretty much put in OTel metrics, and from if you're getting all of the requests, just the HTTP level stuff into OTel, you can also get GraphQL resolvers in there as well. Gotcha. So you can get some really nice sort of breakdowns of calls, which, again, it's one of those entertaining things in life. You go and have a look at a few of the worst ones and try and see what's going on. Some of them are a little unexpected, but obviously at the scale that you're using GraphQL, you really need to stop thinking about individual execution. I mean, it's nice to look at individual execution plans, and yes, it's endlessly entertaining to look at the worst ones just for the hell of it. But you really need to lift the way you're thinking to the overall system and how it's running, and be looking at how do you aggregate those things? How do you detect which are the things that are hot spots in your system? And for the most part, we get that out of OTel related metrics for HTTP and graph stuff. Then we also have our own custom metrics that are used for keeping track of who's using which resolvers and things like that. So that's probably another pretty big thing that turns up for people, is that you want to know, this field that someone added 4 years ago, is it actually being used anymore? And you discover actually, maybe it's only being used on iOS. So then you go and talk to the iOS team, and they go, "Oh no, we're not using it." And you go, "Stop asking for it then."
Gotcha.
So that's probably some of the more custom stuff. But there are paid products that you can use. We've tended to merge that stuff in with some of our other metrics so that we can get different views on things. At SEEK, I think, as at a lot of other companies, you have platform teams that provide you with default ways of doing things. And I think if you're on a team that, say, owns a resource REST API, you're in luck probably, because that's probably the majority use case that someone's going to want to build some sort of default system. And as a lot of companies, we at SEEK have a default system that we're replacing with another default system. Sure. But the point being that that is sort of a default, and naturally the best result of your investment is to hit the majority case, and that's really what our system does. Now, we find on the GraphQL team, while we use that default system, the needs to bend it to our will are quite considerably higher than a lot of other teams. And it's probably one of those things to bear in mind if you're going to head down the GraphQL path, is that not all services are equal. They're not all the same. There's diversity even amongst, REST resource APIs, but, simplistically, you get a request, probably hit one database, maybe two if you're unlucky. But, a bit of business domain processing in memory in a database, and that's it. And for all the ones that follow that format, you can have quite an effective default that works and probably does well over 90% of what people need. But GraphQL isn't the same as that. Yes, it accepts requests, but it then goes on and hits every single API and S3 and some things you really don't want it even looking at. So
I'm going to get some free customer research here. All right, so explain to me. So for a little bit of context, the standard paradigm at SEEK is we have a tool that helps developers deploy containerized services to ECS Fargate. That's our kind of standard tooling. And we're, slowly moving to a more Kubernetes-based platform for various reasons, which are talking to themselves. But so Explain to me some of the challenges you've had with kind of this existing kind of ECS Fargate based deployment system, and what can we do to make that better and easier in the next iteration of that platform?
Well, I'm so glad you asked me. So we've discussed this quite a bit, I think.
Yeah,
so, and we've got stuff that we've experimented with, but I guess one area just does come down to that problem that GraphQL is hitting potentially a lot of different resource APIs. So there's sort of a deep irony in this. Is that, earlier when we were talking about what is GraphQL, I was kind of trying to steer. No, it's not about data sources. It's not about REST APIs.
It's very pure. It's just a graph execution.
Yes, and how nice was it when I was had my little demo app at home and there were no data sources. It was a thing of beauty, and then along came the REST candidate graph, the candidate graph API at SEEK, and unfortunately. Practicality set in, and it actually had to get the data from somewhere. But that's going to be everyone's experience. I think that you have to manage lots of data sources. Now, you inevitably find that, as at any company, you're probably going to have a wide variety of characteristics that the services that you're hitting have. Some of them are super reliable and very fast. Some of them are reliable and slow. Some of them are unreliable and and slow and even slower. Some of them people try and improve, and sometimes they succeed in improving them and sometimes not. Yeah. So all those things, and they're just the realities of our business. You can't sort of get away from that being the actual case of the state you have, as opposed to the one that maybe, in our dreams we wished we had.
Sure.
So you can end up doing a lot of what you might think of as network level operations in the graph, because you're trying to do timeouts. You can think about, you might want to do
retries, perhaps.
Depending on how brave you are.
Yeah, okay.
If you're happy to denial of service yourself, depending on how often you retry from where.
Yep.
Things like rate limiting to APIs, but just anything that's to do with making an HTTP request. You can start programming that into the graph itself.
Interesting.
But the difficulty at that point is you're starting to get, I suppose, the software is trying to do everything.
Sure.
You want your programmers to be thinking, business logic, and in our case, we want them to be thinking about, how do I get my data through to the UI clients in a way that they can consume and that is very, very effective for them. But here they are fiddling around with all of, and then mixed in with the code are all of these little critical bits that are actually trying to deal with network-related activity. So, I suppose, with the system we're trying to move to with Kubernetes and with Istio, there are a whole lot of capabilities where you can implement those requirements at the network layer in Istio, and then suddenly you get this different way of thinking about what you're doing, on simpler systems, and where probably most programmers are used to having that sort of mix of concerns in the code they're writing, and it probably is quite okay on smaller systems. But when you suddenly hit something like GraphQL, where you have lots of network requests involved and lots of different characteristics, do you really want them fiddled in with your software and things that you want programmers thinking of more as business logic for the UI domain? And I think we're probably hitting the limit of doing that at the moment. There's things that we want to do that we could do in the software, but why would you do them in the software if you can split them out and do them at the network layer as a network concern?
Yeah. Now, here's a question and this legitimately, this feels like product research for me because it's very useful. So, would you want to have control? Because I could imagine that, and what we're building in this kind of next iteration of our platform is that you should be able to have controls as a service owner, so as one of an upstream, a resource API owner, as to we're exposing this API at this endpoint, and we'd like consumers to or when consumers call us, if our API is down, we'd like to maybe retry 3 times, or we'd like to circuit break after some amount of failed attempts or something like that. But are you saying that you would actually also want to have that control on the outbound side of the GraphQL server, or would it be sufficient to just have these resource APIs set their own policies about how many retries and circuit breaks they'd want?
Both.
Both. Yeah, okay.
Yeah, I suppose it's going to depend on the nature of the APIs that are concerned. I suppose builders of the APIs are probably going to want to set up their own some of their own requirements as to what they're willing to accept. I suppose the difficulty I can imagine is the graph may be calling an API, and that API may also be getting called by other people.
Yep.
Now, because the graph is essentially a single point of failure to your entire system, there are times when from the graph we might want to just circuit break for a while. We might know, the data from this API, while it's really nice to display, it's just nice to display.
Yep.
Yes, it'd be lovely to have it there all the time, but if their API isn't performing fast enough, or if there's some sort of issues, we would prefer to circuit break on it or do something, and then your system, essentially the website's going to have some form of degraded behaviour for a while because people aren't seeing some piece of information when they go and look at a job, but maybe it's not a necessary piece of information for them to decide whether they're going to apply for the job or not.
Yeah, yeah.
So we would want to have fairly high levels of control over that from the graph, and probably would recognise that we have slightly different requirements than maybe some other user of that API might have.
Yeah, consider that feature request logged, because
excellent.
that would not have occurred to me. Outside of I think this context, I think we're very. It's definitely something that's doable with kind of software-defined routing, but a unique constraint for the graphs that exist at SEEK that we may well need to implement sooner rather than later. So,
yeah. And I think that also leads into probably another area that we're starting to see more and more of, which is this concept of degraded behaviour.
Yep.
I think probably on smaller systems you can think of things as my system is working or not working.
Yeah.
And quite possibly, people higher up in your organisation simplistically think of, well, if I can go to seek.com.au, it's working.
Yes.
And maybe it is, maybe it's not, and maybe that's all they care about. But once your system gets to a certain level, I think that becomes quite an unhelpful way to think about the world. I mean, we'd all like it to be working 100% all the time, but the reality is that we have a mix of services, and due to historical and development reasons, they're all a bit different.
But also, it's preferable to not be just up or down.
Yeah.
If you have the opportunity to be partly up, that's probably better than being fully down.
That's right. Yeah, and I think that's sort of where we're seeing things go. Is that it's be able to think about what's the system is essentially in one sense always up, but it's operating with various degrees of degraded behaviour at certain times, and that you can quantify how severe that degraded behaviour is, because potentially some of it doesn't matter almost at all.
Yeah.
But other parts of it are sufficiently degraded that you would say we're approaching the point where the purpose of the website is unable to be fulfilled now. And so it's much more of thinking about the behaviour of the system on a spectrum, from is it working to is it completely not there. There's an entire spectrum there to think about, and that really, in terms of implementation details, starts to get down to how can you manage the network requests, because Most of the time, it's going to be, a request from the graph calling something else that is misbehaving for some reason, maybe due to the service itself, maybe because it's being bombarded because some back-end process decided it would be fun to set off, a 50 million entry repopulation at a certain time. When we've had that happen at SEEK, and the person doing it didn't even realise that that's what was happening because the system was sufficiently complicated. They didn't realise. So those things happen inadvertently, and you don't want them to bring your website down, preferably, or your system. So I think there's a whole interesting area there in terms of how you think about the behaviour of the website or the apps or whatever, and the service that you're providing to customers, and is it working or not working, and then implementation details when you get to observability and ability to manipulate the network.
Absolutely. I hope that's where we're heading. I think that's where we're heading.
I think so. It's looking good so far.
Yeah, that's good to hear.
I think the takeaway from the session today is that, in the immortal words of Uncle Ben, with great power comes great responsibility. With great flexibility, equally great responsibility. Get yourself an A-team who can put a plan together. I'm just going to keep dropping just references to shows and movies. No, it's good. I found this really interesting. I appreciate your time today, Mark. I think GraphQL is one of those things where, because so many of us have to consume it, like I've said before, we just kind of detach from the underlying, or I guess the core behavior, the core thing that it is, and just start to deal with the bits that we need to deal with without thinking about it. So it's nice to think a little bit more deeply about some of the pros and cons that maybe not all of us have had to face. It's been really interesting. Thank you very much.
Thank you.
This has been another SEEK Bytes. Oh, no, I was about to say SEEK Bytes podcast, and then I was going to say the other bit. What is it?
It is SEEK Bytes, right?
Yeah, but I was going to say SEEK Bytes podcast, the engineering podcast. By engineers, for engineers. And I'm trying to say podcast 2 times in a row really quickly.
It's been another SEEK Bytes.
This has been your SEEK Byte. The engineering podcast by engineers for engineers. Thanks for listening, and we'll catch you next time.